Hello there, and welcome to this video on SHM. In this case, we're comparing pendulums and mass spring systems. I'll leave you to have a look, and then when you're ready to see the answer, press play. Okay, as I mentioned in the introduction, this is a question where you're comparing pendulums and mass spring systems, and it's a really common one that I've noticed that comes up in a lot of IB papers. The first thing to look at is just the general task. We've got oscillations on Earth that are periodic with time period t. So we've both got time period t. Okay, they are then taken to the moon, and we're asked to consider what will happen to these systems when they move to an area with lower gravity. Okay, so let's have a look at this. The first thing to do would be to pull up our equations. Okay, we know that for our two systems, for example, our pendulum Tp is going to be the oscillation, which is given by 2 pi times the square root of L over G. You notice there's G in there, so we're expecting our pendulum to change in some way. If we compare this with that for the mass spring system, there is no G in our equation, and therefore actually our spring is not going to change its behavior. So actually, we're looking at our answers there. We can already rule a couple of them out in that T for the mass spring system, I should say, is going to stay the same. Okay. We know that for the pendulum, as G goes down, we've got an inversely proportional relationship, and therefore its period is going to increase. Okay, and as I've just stated, well, in the spring, there's no change. We've just simply got the same value. Okay, so we can start looking at our combination of answers here, and hopefully you can see that the only one that fits what we've just said there is B, where the pendulum will have a period greater than T, and the mass spring system will simply have a period equal to its original period, which is T.